One way to save money on energy costs is to use the heating and cooling power of the Earth itself. Today, let's dig into learning more about geothermal systems. Home geothermal systems are a form of renewable energy because they extract energy stored in the earth without burning any fossil fuels. We're with an expert today from E&J Geothermal. This is Tom Rutkowski. And Tom, you guys use energy from the earth, but not fossil fuels. Can you tell us about that?
That's correct. So we have geothermal heat pumps. They're electrically powered. We don't burn any fossil fuels in the process of operating our units. And geothermal units harness the heat that we store in the ground as a thermal battery to heat and cool your house.
Now, when you talk about exchanging heat, just to clarify, you're talking about a home's heating and cooling, correct?
That's correct. So heat pumps do your heating and cooling. So it's all about moving heat. So in traditional heating season, we're going to take BTUs that have been stored in the earth, bring them in, and then through a refrigeration cycle, bump them up to a warm temperature you feel coming out of a vent. Adversely, in the summertime, we're going to take the heat that's built up in your house and move that heat out into the ground.
What makes geothermal heat pumps so energy efficient?
It's how we transfer that heat. So if you can imagine in summertime with normal air conditioning, you're taking heat from the house, trying to move it outside to a condenser and move heat into more heat. It's not a very efficient process. For us, we take that heat in the house and we move it down to the ground where it's a very consistent 50 to 55 degrees. And the more temperature difference you have, the easier that heat wants to move. So because there's a bigger temperature difference, it moves easier. We're using a liquid instead of air, and heat moves easier through liquid than it does air, so there's more efficiency there. And then heat pumps or compressors in general are the only type of heating equipment where you are more than 100% efficient. So for every kilowatt we use an electric to power that heat pump, we're going to get about 3.5 kilowatts worth of heat.
Let's talk about where we are. This is a location that's in process of having a system put in, right? What were the conditions that had to be there in order to make this a good fit for geothermal?
Sure, so with any house or any project in general, we're going to look at a few things. A, making sure there's enough ground, and then what the ground consistency is. Is it soil, is it sand, is it clay? To determine how much pipe we need in the ground to match that unit we're putting in the house. We're going to look at the house itself. Is it spray foam, is it fiberglass? To determine a proper heat load, so we know how much heating and how much cooling you're going to need in order to keep that house comfortable, both in heating and cooling season.
Okay, does it need a certain amount of space?
There is an amount of space that it needs, but that varies depending on what type of loop installation we're doing. There's several different options out there. We can do a slinky loop, which is where you typically see a larger hole dug. We can directionally bore. We do a lot with retrofit applications. If there's very limited room or if we need a lot of tonnage in a small space, we can go with a vertical loop. And then sometimes we can even use ponds.
So my understanding is there are several different types of geothermal heat pumps, right? There's water to water and water to air. Why would you select one over the other?
A water to air heat pump is one that's going to create hot or cold air. It's a more common unit. We're going to see that more when we're either taking a furnace and air out or just designing a home where there is no radiant, it's just traditional forced air ductwork. A water to water unit operates on the exact same principle, but instead of making hot or cold air, we make hot or cold water. This is where we're typically going to see applications where we're doing hydronic heat, in-floor heat. And then in the summertime, those water-to-water units create chilled water, which we can run to various types of air handlers for cooling in the space.
All right, well, why don't you show us where you are in the installation process now?
Sure, let's go take a look. So Megan, here we've got our mechanical room. Like I said, this is a house that's under construction, but I'll walk you through a typical geo setup for this type of house. So right here we've got all of our geo loop piping. This is what we were talking about, that how we'd either do slinky or directional boring. But that pipe comes up on the wall and manifolds, and something unique that we do, we put all of our manifolding interior to the structure. We do that for a couple reasons. One, if one of them does get hit, you can isolate it and you're still up and running on everything else. We also put these ball valves in here from a test and balance standpoint, so if we need to adjust flow to balance things out so we get that proper heat exchange, we have that ability to do so. So working our way from the manifold, we come over to the standpipe. So this loop setup is a horizontal closed loop system. So it's on its own sealed system. There's antifreeze inside of here. We're not adding water to it constantly. And the water level typically sits right in this mid-level here. As that pipe in the ground starts to heat up and cool down, it is going to expand and contract slightly. So the volume of water inside that pipe will go up and down depending on what is going on with the loop.
So that's like a reservoir of water, basically.
It's a buffer tank for your ground loop, basically. From the standpipe, we come out to another manifold, and then we have our loop circulating pumps. So these pumps are what are actually pushing the fluid through the ground and feeding the geothermal unit. We put isolation valves on the pumps. That way, if we ever have to change one out, it's very easy to do so and not have everything come out of the pipe. So the piping comes around, and then it hits our geothermal units. So on this setup, we've got a few units. They all come over, and they start to feed into a buffer tank. Now, that buffer tank can vary depending on how much flow we need. On this particular project, we've got a lot of flow that can go out to air handlers, and we're not really needing as large of a buffer tank. So we built a standpipe for the same reason. It acts like the buffer tank. Coming off there, we've got our load side pumps. So this is what's actually moving the hot or chilled water to its designated area. So whether that's feeding an in-floor heat manifold or running to a chilled water air handler for the cooling portion of the project.
Now you have 3 units here. Is that typical?
It depends on the size of the house. So remember I said how we do that load calculation to determine what unit. This particular house, we ended up having to go to several units to make sure they had enough heat and cooling to meet that demand.
Okay, so it varies depending on the circumstance.
Exactly.
What are the benefits that these homeowners are going to feel right away?
And the biggest things are going to be comfort and efficiency. Operating costs for this type of system, it's going to be about 1/3 or even less compared to a traditional, in this case, boiler or air conditioner. And then the comfort, you know, the whole idea of it being low and slow, in this case having radiant heat, it's just going to feel more comfortable than a traditional fossil fuel or burning type heating application.
I love that. So the big question now is cost. Can you do a little comparison between a conventional heating and cooling system versus a system like this?
Sure, so up front it's going to be about 30 to 40% more because we're putting that ground loop in. But because of the tax incentives and the local utility rebates, it ends up being a wash, or in this case, sometimes even less than putting in a boiler and air conditioner.
That's great. You have given us so much to think about. Thank you for all the clarification.
Not a problem.
And if you'd like to learn more about geothermal or other high efficiency HVAC systems, go to PowerHouseTV.com.